All right, so today's class in our unit factors and multiples, today we are looking at multiples, and we will also be looking at prime and composite numbers. So firstly, what is a multiple? So a number m is a multiple of another number f if the number f divides evenly into the number m, or if the number f is a factor of the number m, as shown in the examples below. That's a very confusing definition. But what the set of multiples of 7, for example, it's just like the multiplication tables. So if we were looking for the set of multiples of 7, you would just start by multiplying 7. 7 times 1, which is 7. 7 times 2, which is 14. 7 times 3, which is 21. 7 times 4, 28. 7 times 5, which is 35, and so on. It will keep going. Right? So multiples, they will continue forever. So usually when we're listing out the set of multiples, you would usually just list out like the first 5. All right, and always start with the first one, which would be the number multiplied by 1. Right, so here, list the set of multiples of 9. So again, listing out the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3. 9 times 4. 9 times 5. All right, and then you would show those 3 dots to show that that would continue infinitely. All right, so normally when we are looking at a question, it will say write the first 5 multiples for each. We just did 9, so let's change this one. Let's change it to 4, and we'll do 5. All right, so in the private chat, please. Okay, so for multiples of 4, we would start with 4 times 1, which is 4, then 8, then 12, 16, and then 20. All right, so 1, 2, 3, 4, 5. Those would be the first 5 multiples. All right, for 5, first multiple would be 5, then 10, 15, 20, and 25. So again, 1, 2, 3, 4, 5. Those would be the first 5 multiples. All right, next type of question you may see, circle the number in the sets which are multiples of the given number. So our given number is 5. Which ones are the multiples? Those are the ones we would circle. Same thing for 12. So looking at this question then, which are the multiples of 5? So 5, 10, 15, 25, 40, 95 would all be multiples. 104 and 204 would not be multiples. 305 would be multiples. So we have to circle them. Instead, I just crossed out those 2. All right, so recall when we were looking at divisibility rules. If the numbers ended with 5 or 0, we know it was divisible by 5. All right, next we have the number 12. Which ones are multiples? Which ones are not? All right, so looking at 12. 12 times 3 is 36. 12 times 4 is 48. So 44 we would cross out. 56, I think 12 times 5 is 60. So 56 we could cross out. 98 is not a multiple either. 132, yes, that works. 12 times 11 gives me 132. So 36 and 132 are multiples of 12. So next we are looking at prime and composite numbers. So a prime number, it is a number that has only 2 factors, the number 1 and the number itself. So for example, the number 2, number 3, 23, 47, 17, 37. All of those numbers, they only have two factors, the number 1 and the number itself. So it would be considered a prime number. So a composite number is any number that has more than two factors. So for example, 4, 25, 35, 62, they have more than two factors. All right, so if we were listing out the factors of 2, right, it's just 1 and 2. So therefore, it's a prime number. Same thing with the number 3. The only two factors of 3 are 1 and 3. If we were looking at the factors of 4, we have 1, we have 4, but we also have 2. 1 times 4 gives us 4, and 2 times 2 gives us 4. So 4 would be a composite number. Another example they say is 25. So 1 and 25, but then 5 times 5 are other two factors of 25. All right. If we were to do 8, the number 8, so 1 and 8 are factors, but so are 2 times 4 would also give us 8. All right, so that's the difference between prime numbers and composite numbers. The number 1 is considered to be neither prime nor composite. All right, so it doesn't fall into either category. All right, so let's do these examples here. List the factors of each number and then decide, is it a prime number or is it a composite number? So start with the number 27. 2 we already did. We just did it over here. So don't worry about doing number 2. Start with number 27. So just starting the recording here. So list the factors of each number. So 1 and 27, but then also 3 and 9 also gives us 27. So therefore, this would be a composite number. I'm just going to put C there. 2 we had already done. The only two factors for 2 are 1 and 2. So therefore, this is a prime number. For 79, there's only two factors for 79, just 1 and 79. So therefore, it is prime. For 51, it looks like it would be prime, but we have 1 and 51, but then also 3 and 17 give us 51 as well. So that would be a composite number. All right, so we were here listing all the numbers less than 17 that were composites. We made our list here. 4, 6, 8, 9, 10, 12, 14, 15, and 16. And just here were the prime numbers that were less than 13, so 2, 3, 5, 7, and 11.